All right, this is lesson 3 of unit 2, and we're going to keep going with functions. And so we've got these things called parent functions. So these are things that when you see a certain function, like a linear function or a quadratic function, you kind of want to have this picture in your mind. So again, a linear function is very basic. It's going to be a straight line going at an angle. So this will be a positive linear function. And we would say that our y-intercept here is 0. So the y-intercept is where your line crosses the y-axis. So this is, again, the parent function of a positive linear function. So if I were to say, hey, I wanted you to graph y equals 3x. In your mind, you would be thinking, hey, I know that it's going to look something like this. It might be steeper. It might be less, like not quite as steep, but it's going to look something like this. So we've got any kind of a form for this, and it's called slope-intercept form. So slope-intercept works like this. Y equals mx plus b, where m is my slope and b is my y-intercept. So if I look at my parent function, again, let's just say that this is a slope of 1. Here's 2. Here's 3. So again, I would say that this has a slope of 1 and a y-intercept of 0. Of course, we don't need to write plus 0. So we could just call this line y equals x or y equals 1x. But what if I wanted to graph y equals 2x? Okay, let's take a look. So I'm going to start by graphing my line right here. And I'm going to start with the parent function. So the parent function, again, is y equals 1x. So for every time x increases, y increases as well. So 1, 2, x is 1, y is 1, x is 2, y is 3, so on and so forth. But I want to graph the function y equals 2x. So again, my y-intercept is still 0, but my slope, which slope is rise over run, is going to be up 2 over 1, up 2 over 1, up 2 over 1. Okay, so as I graph this, I can see, oh yeah, my slope is much steeper than my parent function, which was y equals 1x. My slope y equals 2x is much steeper. Now you can also graph a function and you can change your y-intercept. So let's look at the equation y equals x plus 3. My slope is the same as my parent function. However, my y-intercept is different. My y-intercept is plus 3. So I'm going to say, okay, instead of starting at 0, I'm going to start at positive 3. I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. Okay? So I can say, hey, yes, my slope is the same, but I can also change the y-intercept. So the difference is that sometimes we're going to change the slope, sometimes we're going to change the y-intercept, and sometimes we're actually going to change them both. So let's do another example. Let's draw our x-axis here. And I'm going to say I want to graph the equation negative 2/3 x subtract 1. So start with your y-intercept. So I'm going to say my y-intercept is negative 1. And then my slope, if I look here, is negative 2/3. So I'm going to go down 2 over 3. Down 2 over 3. And it gets a little goofy because I have the page break here. You can see that they're not quite the same size. So again, I could say, well, I want to go up 2, but again, I still have to account for this negative. So I'm going to say up 2, but now instead of going to the right 3, I'm going to go to the left 3. So you got to graph at least 2 points to create your line. I would recommend doing 3 That way you get a more accurate line. So again, sometimes I'm going to change the y-intercept and the slope as well. All right, let's kind of do a multi-step problem. So the body length y, which is in inches, okay, of a walrus, can be modeled by y equals 5x plus 42, where x is the walrus's age in months. Okay, so y is body length, and x equals age in months. So if I start with my kind of x-axis, x and y-axis here, I'm going to start by graphing the equation. So let's count by tens. So we're going to call this 10, 20, 30, 40, 50, 60, so on and so forth. Okay, and then I'm going to count by twos for the months. So this is body length, and then this is my x-axis is age. So let's say 2, 4, 6, 8, 10, age in months. So I'm going to start at 42. So 42 is about right here. That's my y-intercept. And then I'm going to go up 5 and then to the right 1. So up 5 to the right 1, up 5 to the right 1, up 5 to the right 1, up 5. Hold up. That's going to be at 42. So it's going to be about right here. Up 5 to the right 1. Perfect. So I can see that as I graph this, I could calculate the walrus's body length compared to how old they are. So interpret the slope and y-intercept. So again, my slope is 5, and then my y-intercept is 42. So that means that at birth, at age 0, the walrus is 42 inches long, and the slope is 5. So that's the calf's rate of growth per month. So that means that they are going to grow 5 inches per month. Now, if the question wanted me to estimate the body length of the calf at age 10 months, well, again, I could try to graph it and I could say, where is it at 10 months? Or I could go ahead and plug in 10 for x and then solve it. So let's do that. So every time I see an x, I'm going to plug in a 10. 5 times 10 is 50 plus 42. So I could estimate that after 10 months, the walrus is going to be about 92 inches. So this is slope-intercept form, okay? Right here. We just got done talking about slope-intercept form. We can also write out equations in something called standard form. Standard form. And so standard form goes AX plus BY equals C. So that's kind of our generic form, I guess, for standard form. AX plus BY equals C. So A and B cannot be 0, and you can graph an equation in standard form by identifying the X and Y intercepts. So again, very similar to a y-intercept, the x-intercept is where it crosses the x-axis rather than the y-axis. So if I were to say I have the equation, let's see here. I don't like that color green, it's hard to see. So maybe the question is graph 5x plus 2y equals 10. So if I want to figure out what the x-intercept is, again, if you think about how the x and y, if the x-intercept is on this line, okay, my y equals 0. Similar, okay, if I'm trying to find the y-intercept, what's my x value going to be? X equals 0. It has to be x equals 0 on the y-intercept. The x-intercept has to equal y equals 0. So I can go ahead and just input or plug in those values. So let's find our x-intercept. So to find our x-intercept, I'm going to make y equal to 0. So I have 5x plus 0 equals 10. So I'm going to do, again, don't need plus 0. That doesn't do us anything. So I could divide by 5. So I could divide by 5. And so I found my x-intercept to equal 2. Now let's do that exact same thing, but calculate the y-intercept. Again, when I find the y-intercept, my x value is 0. So 0 plus 2y equals 10. Well, again, I don't need that. 2y equals 10, divide by 2. So y-intercept equals 5. All right, now let's take this information and graph it. So I've got an x-intercept of 2, 1, 2, and I've got a y-intercept of 5, 1, 2, 3, 4, 5. So I could go ahead, again, need at least, oh, that was not straight at all. Let's try that again. Need at least 2 points to be able to graph a line. And just a reminder about graphing horizontal and vertical lines. Okay, so say you get a problem and it says, hey, graph y equals 2. Well, y equals 2 is a horizontal line because anywhere on this line, 1, 2, 3, y is going to equal 2. Whereas same thing, if you want x equal to -3, -1, -2, -3, it's going to be a vertical line because anywhere on this line, my x is going to equal -3.